Well, I will teach you the complete concepts of units and measurement. The first concept of this chapter is physical quantity. Anything which we can measure is called physical quantity. For example, we can measure temperature like 40 degrees centigrade. So temperature is a physical quantity. We can measure length of a room like 30 meters. So length is a physical quantity. We can measure time like 5 minutes. So time is a physical quantity. We can measure mass of anything like 2 kg. So mass is a physical quantity. Secondly, we know that we cannot measure happiness. So it is not a physical quantity. We cannot measure sadness. So it is not a physical quantity. Therefore, we say that anything which we can measure is called physical quantity. Remember that every physical quantity has two parts, magnitude and unit. Now, what is magnitude and unit? Well, magnitude is a numerical value or simply a number like 40, 30, 10, etc. While unit is used to measure any physical quantity. For example, let I write 10 hours. We can see that 10 is a magnitude and hour is a unit. This unit of hour tells us about the time. Therefore, remember that magnitude is a numerical value and unit is used to highlight the respective physical quantity. Now we will learn types of units. Remember that there are two types of units. The first one is base units and the second one is derived units. Firstly, what are base units? Well, a set of 7 fundamental units and a system of measurement is called base units. The 7 base units are second, meter, kilogram, Kelvin, mole, ampere, and candela. Note down that second is represented by S, meter is represented by M, kilogram is represented by kg, Kelvin is represented by K, mole is represented by MOL mole, ampere is represented by A, and candela is represented by CD. Here, let me teach you my personal trick to remember these 7 base units. I say ACKKMMS. Here, A stands for ampere, C stands for candela, K stands for kilogram, this K stands for Kelvin, M stands for meter, this M stands for mole, and this S stands for second. Thus, using my personal trick, we can easily remember the 7 base quantities. Now, what are derived units? Well, those units which are derived by multiplication or division of the base units are called derived units. For example, consider meter and meter. Now, I multiply them. I get meter squared. We know that it is a unit of area. We know that this meter and this meter is a base unit. This meter squared is a derived unit because it is derived from multiplication of 2 base units. Secondly, consider this meter and second. Now I divide them. I get meter per squared. It is a unit of speed. We know that meter and speed both are base units, while this meter per second is a derived unit because it is derived from division of 2 base units. Thus remember that derived units are those units which are derived from base units. Now we will learn SI units. We know that SI unit stands for System the International Units. In the past, there was a big problem while dealing with units. For example, in Europe, mass was measured in pound, while in Asia like Pakistan and India, mass was measured and say it was a problem. I mean, two different units were used for the same physical quantity, mass. Now to solve this problem of different units, International System of Units is introduced, which we call SI units. The main purpose of SI units was that all units can be easily communicated internationally. Let me repeat it. The main purpose of SI units was that all units can be easily communicated internationally. Now what is SI units? Well, the 7 base units that have been agreed upon by international agreement is called SI units. We already know the trick, ACKKMMS, where A stands for ampere, C stands for candela, K stands for Kelvin, K stands for kg, M stands for meter, this M stands for mole, and S stands for second. These are the 7 SI units. Hence note down this list of SI units. Now we will learn scientific notation. Firstly, let me ask you one important question. Why we study scientific notation? Well, to save space and to save time, we study scientific notation. For example, the mass of the moon is 7 into 10 raised to the power 22 kg. It is a very big number. If we write it, it will be 700 up to 270. It is too big number. Now to save space and to save time, we use scientific notation. We write it in the scientific notation as 7 into 10 raised to the power 22 kg. Secondly, the diameter of an atomic nucleus is 1 into 10 raised to the power minus 14 meter. It is a very small number. If we write it, it is like 0.000 up to 14. It is too small number. Now to save space and to save time, we use scientific notation to write it 1 into 10 raised to the power minus 14 meter. Thus remember that we use scientific notation to save space and time. Now we will learn writing scientific notation. Let's consider this number. Firstly, we spot the leading digit. Here the leading digit is 7. There is no decimal point present in this number. I put decimal point at the end. Now listen carefully. If I move the decimal point to the left, the exponent or power of the 10th is positive. Here I move the decimal point to the left. 1, 2 and 3. I leave the living digit 7 and I put decimal point after 8. I write 7.245 into 10. I have moved the decimal point 3 times to the left. I write positive 3. I write positive 3 as exponent. So I get 7.245 into 10 raised to the power 3. This is called scientific notation. Secondly, consider this number. We can see that the leading digit is 3. There is no decimal point present in this number. I put decimal point at the end. Now I move the decimal point to the right. 1, 2, 3 and 4. I put the decimal point after the leading digit. I write 3. Here all the digits are 0. Remember that we do not write them. We have moved the decimal point 4 times. I write plus 4 as an exponent. So I get 3 into 10 raised to the power 4. This is called scientific notation. Thirdly, consider this number. Here the decimal point is already present. I move it to the left. 1 and 2. I put it after the leading digit. I write 4.2 add 6, 3 and to 10, I have moved 2 times the decimal point to the left. I write 2 as an exponent. I get 4 point, add 6, 3 and to 10 raised to the power 2. This is called scientific notation. Now consider this number. Remember that 0 cannot be a leading digit. Let me repeat this important point. Remember that 0 cannot be a leading digit. So here the leading digit is 3. Now listen carefully. If we move decimal point to the right, the exponent will always be negative. Here I move this decimal point to the right. 1, 2, 3, 4, 5. I put this decimal point after the leading digit. I write 3.12 and to 10. I have moved the decimal point to the right 5 times. I write minus 5. So I get 3.12 and to 10 raised to the power minus 5. This is called scientific notation. Therefore, using this simple method, we can easily convert any big or small number to a scientific notation. Hence note it down. Now we will learn significant figures. Well, I teach this easy analogy to master significant figure. Let's consider this hungry man. We know that this man needs some sort of food. Because food is important, certain and reliable source to kill his hunger. Secondly, let's consider that he adds some sort of fruit to his menu. Here, let me ask you, is fruit that much important to kill his hunger? The answer is no. It is not that much important, but we cannot ignore its importance. I mean, fruit is necessary. Similarly, let's consider this table. Let the length of this table is 25.1 centimeter. Here, before the decimal point, there are 2 digits. They are certain digits and reliable. While after the decimal point, there is only 1 digit. It is not that much important like fruit, but it is necessary. I mean, we cannot ignore its importance. Thus we say that there are total 3 important digits and 25.1 centimeter. Or we say that there are 3 significant figures and the length of this table. Remember that this length of the table contains certain and necessary digits. Therefore, we define significant figure as the certain and necessary digits in any measurement is called significant figure. Let me repeat it. The certain and necessary digits in any measurement is called significant figures. Hence, note down this fundamental concept of significant figures, which a lot of students are not understanding. Now I will teach you super easy trick to find significant figure in any measurement. We know that there are 2 types of numbers, non-decimal numbers and decimal numbers. In non-decimal numbers, to find significant figure, always remember this trick. Go from first non-zero digit to the last non-zero digit. For example, consider these numbers. In this number, the first non-zero digit is 5 and the last non-zero digit is 2. So all these digits are significant figure. I count them. 1, 2, 3, 4, 5, 6. Thus there are total 6 significant figures present in it. Secondly, in this number, the first non-zero digit is 2 and the last non-zero digit is 3. So I go from 2 to 3. 1, 2, 3. Thus there are total 3 significant figures present in it. Thirdly, In this number, the first non-zero digit is 4 and the last non-zero digit is 1. I go from 4 to 1. 1, 2, 3, 4. So there are total 4 significant figures present in it. While in case of decimal numbers, we say that to find significant figures, go from non-zero digit to the last. For example, consider these numbers. In the first number, the first non-zero digit is 5. I go from 5 to the last. 1, 2, 3, 4. Hence, there are 5 significant figures present in this number. In case of second number, the first non-zero digit is 7. I go from 7 to the last. I count them. 1, 2, 3, 4, 5, 6. So there are 6 significant figures present in it. In case of third number, we can see that the first non-zero digit is 4. I go from 4 to the last. I count them. 1, 2, 3, 4. So there are 4 significant figures present in it. Thus, using this trick, we can easily find significant figure in any measurement. If you want to learn more about significant figures, watch our lecture and its link is given in the description. Now we will learn the important concept of accuracy and precision. Accuracy means how close a measurement is to the actual value. For example, consider this man. Let the actual height of this man is 3 meters. Here are these 3 students. I ask them to find the height of this man. Let the first student measure that the height of this man is 4 meters. Let the second student measure that the height of this man is 2 meters. While the third student measure that the height of this man is 3 meters. Now listen carefully. There are 3 different values in this measurement. The 2 values are totally wrong, but 1 value is correct. So we say that this is accurate measurement or it has high accuracy. It is because this third value of the measurement is intersecting the actual value. Thus remember that even if one value in a measurement is matching the actual value, we say that it is accurate or it has high accuracy. On the other hand, precision means how 2 or more values in a measurement are close to each other. For example, consider this man from the previous example. Let the actual height of this man is 3 meters. Now I ask these 3 more students to measure the height of this man. Let the first student measure that it is 2.5 meters. The second student measure it is 2.4 meters. And the third student measure it 2.6 meters. Here, let me ask you, is this measurement accurate or it has high accuracy? The answer is no. It has low accuracy or it is not accurate because the values in the measurement do not match the actual value. Hence we say that it has low accuracy. But here, this 2.5 meter is close to 2.4 meter. And this 2.4 meter is close to 2.6 meter. These measured values are close to each other, hence this measurement has high precision. Let me repeat it. These measured values are close to each other, hence this measurement has high precision. Therefore we say that this measurement has low accuracy but high precision. Hence note down these important concepts. Now I will teach you some questions based on the concept of accuracy and precision. Let's consider that a scale measures the mass of an apple as constantly as 0.5 kg